For the past few weeks, I have been able to record hours of video of the American robin, Turdus migratorius. These birds spend several hours of the day split up into morning, midday, and evening sessions on the ground foraging for worms and insects. Along with smaller invertebrates, they also consume berries and small fruits, particularly in the winter, and they tend to prefer feeding in lawns, parks, and fields near wooded areas. Here you can see a male robin foraging. He quickly runs forward, then pauses, runs, makes prey strikes, tilts his head, potentially to focus, and continues along. Similarly, a female here performs a hop-hop, pause, head tilt, strike, and you'll continue to see this ritual in more footage. So how is this behavior occurring? What could cause a certain foraging behavior? A characteristic foraging action is the head tilt, where the robin will bend forward and turn its head so one eye is facing the ground. My causation hypothesis is that robins tilt their heads to the ground in response to visual cues about prey location. Researchers like Frank Hepner in 1965 has studied what sensory cues robins base their prey capture on. What he did was a combination of field observations and testing in captivity to observe how different types of sensory cues influence worm finding ability. The birds ignored all cues other than the visual presence of worm parts, to which they responded with head tilts and prey strikes. So how does foraging develop? When young robins start to leave the nest, they follow their parents around on the ground, watch them hunt, and receive food from them. Conspecific observation and, more importantly, practice are both required to learn the correct prey to target, to improve beak-eye coordination, and to adapt to environmental challenges such as predators, light, intensity, prey abundance, and competition from dominant birds. My development hypothesis is that juvenile robins acquire foraging skills through observing experienced adults and trial and error. Vanderhoff and Eason in 2007 studied foraging adult and juvenile robins for 22 days in a park in Louisville, Kentucky, and compared their successful and unsuccessful prey strikes per minute. They found that the juvenile capture rate for invertebrate prey was 69%, compared to 80% for experienced robins, and that juveniles had to make many more capture attempts to compensate for their foraging inexperience. Now we ask, why is this behavior occurring? Is there a phylogenetic connection? My evolution hypothesis is that American robin foraging rituals are very similar to those of other thrushes. Blackbirds and song thrushes, both in the Turdus genus with the American robin, as noted from Smith in 1974 in Central Oxford, exhibit a series of short linear rushes made up of one or more hops or steps, separated by short pauses during which the birds move their heads and bodies, apparently scanning the environment, and during which they may peck at food items, dead leaves, or other objects, mirroring the hop-hop, pause, scan, strike behaviors I observed. Why is such foraging behavior selected for? My function hypothesis is that robins that are more successful foragers can better feed their offspring and increase their reproductive success. Swihart and Johnson, 1986, researched the trade-offs between robins foraging to feed themselves versus to feed nestlings, based on a population in Kansas, and found that as the offspring grew, parents had to increase their foraging activity, but that they tended to carry back larger prey items to their young, so they were also less likely to forage as much further from the nest. A lot of energy goes into finding and transporting food, so those birds with better site selection or capture skills tend to be able to feed themselves and then also provide more nourishment to their young. Relating robin foraging to lessons we've learned this semester, an overarching theme is the cost versus benefit nature of an animal's decisions. Optimal foraging theory clearly connects to the observed behavior. We expect that feeding behavior is aimed to maximize net energy gains, so robin foraging site selection may fit with the marginal value theorem, or their decisions during breeding season may be influenced by nest site central place foraging. Foraging prowess can indicate ability to provide direct benefit to a mate and to be a good parent. Pairs often stand guard for each other, as you see here. There is also a cost-benefit conflict of parental sacrifice in nourishing offspring. I did try my own experiment and laid out raisins in various places and configurations on several occasions to see if the robins would opportunistically feed on them over invertebrates, but was met with universal disinterest, even when attempting to entice them with a bird bath. So it would be great to investigate that decision-making further. There are clearly many interrelated animal behavior concepts when it comes to feeding behavior in robins, and I hope you've learned a lot about them today.